Welcome to the session on differentiation, gradients, tangents, and normals. The objectives for this session are to use the derivative to solve problems involving gradients, tangents, and normals. Recall that for all real values of n and constant a, if y equals ax to the power n, then dy dx equals an times x to the power n minus 1. Also, if y equals f of x plus or minus g of x, then dy dx equals f dash of x plus or minus g dash of x. Let's now take a look at tangents and normals. The normal to a curve at point A in the diagram is the straight line through A which is perpendicular to the tangent to the curve at A. So here's the tangent at A, and here's the normal at A. You can see that it's at right angles to the tangent. Consider a general curve y equals f of x at the point capital A equals little a, f of little a. The tangent to the curve at A is y minus f of a equals f dash of a times x minus a, where f dash of a is the gradient to the tangent. The normal to the curve at A is y minus f of a equals minus 1 over f dash of a times x minus a, where minus 1 over f dash of a is the gradient to the normal. Here's a summary of the key points. We're going to look at an example in order to understand some of these points in greater depth. Find the equation of the tangent to the curve y equals 5x cubed plus 2x squared minus 3x minus 1 at the point 1, 3. Let's solve this. So we have y equals this cubic, and therefore the gradient of the tangent is dy dx equals 15x squared plus 4x minus 3. We've used, of course, the formula dy dx equals an times x to the n minus 1 for each term. And therefore, when x equals 1, the gradient is 15 times 1 squared plus 4 times 1 minus 3, which is equal to 16. So the equation of the tangent at 1, 3, substituting in this equation for the tangent at A, is y minus 3 equals 16 times x minus 1. This is where we get 16 from, and this is where we get 1 from, and this is where we get 3 from. And therefore rearranging gives us that y equals 16x minus 13. Now let's take a look at another example. Find the equation of the normal to the curve y equals 8 minus 3 cube root of x squared at the point where x equals 8. So let's solve this. Rewriting y gives us that y equals 8 minus 3x to the power 2/3. So the gradient of the tangent is this. Of course, when we differentiate a constant, we simply get 0. And for the term minus 3x to the power 2/3, we use n equal to 2/3 and a equal to minus 3. And so tidying up gives us minus 2x to the power minus 1/3. So when x equals 8, we have y equals 8 minus 3 times cube root of 8 squared. And tidying up gives us 8 minus 3 times 4, which equals minus 4. So when x equals 8 and y equals minus 4, the gradient is minus 2 times 8 to the minus 1/3. We've simply substituted x equals 8 into the formula for dy dx. And tidying up gives us this expression, which equals minus 1. Now the gradient of the tangent times the gradient of the normal equals minus 1. And therefore, the gradient of the normal is equal to 1. We can now find the equation of the normal, which is y minus minus 4 equals x minus 8. Here's the gradient of the normal. Here's the 8, which we subtract from the x. And here's the minus 4, which we subtract from the variable y. And then rearranging this equation gives us y equals x minus 12. This brings us to the end of this session. If you have understood its contents, you should be able to use the derivative to solve problems involving gradients, tangents, and normals. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.